So I can use the same trick to cancel these two. And then I have bj plus bk is 0, bj prime plus bk prime is 0. Is it possible for that to happen if bj is not equal to bj prime and bk is not equal to bk prime? Clearly it is. So, for instance, if bj is 0, bk is 0, then that's 0. If bj prime is 1, bk prime is 1, then that's 0. So this is possible. So it is possible for code words to differ in two places. Okay, so what does this mean for error detection? Okay, it is in C, which is the single parity check code. Then it is impossible for code words to differ in one place, but it is possible for code words to differ in two places. So in other words, if I take the minimum over all C1 and C2 in the code, over all code words in the code, the minimum of the Hamming distance, what is the minimum possible Hamming distance between any two code words? 2. 2, obviously, by these arguments. So we define this as the minimum Hamming distance. Okay, if the minimum Hamming distance is 2, in other words, let's forget about the single parity check code for the moment, and let's say I give you a code, and I say its minimum Hamming distance is 2. Using that code, can we detect an error? Let's back up for a second and say, what is true about a code if the minimum Hamming distance is 1? If the minimum Hamming distance is 1, then there exist at least 2 code words that differ in exactly one place. So therefore, if an error occurs in that place, I can't detect it. If a single error occurs in that place, I can't detect it. If the minimum Hamming distance is 2, then what happens if a single error occurs? If a single error occurs, then any one bit is flipped. But because the minimum Hamming distance is 2, it's impossible for that single bit flip to flip one code word into another code word. So therefore, a single error will cause, take a code word and turn it into something that is not a code word. So if I'm only allowed to transmit code words, then that error is detectable. Yes?
How about for 2 errors?
2 errors. So if the minimum Hamming distance is 2, then there exist at least 2 pairs of code words, or at least 1 pair of code words that differ in 2 places. So errors in both of those places, will be undetectable. So can we generalize? So if, let's call this minimum Hamming distance is defined by this equation. Let's assign that the symbol dmin. And the code will be implicit. So if dmin, for a code, if it's not 2 anymore, but we just make it abstract. So for a code C with minimum Hamming distance dmin, then if my minimum Hamming distance is dmin, So think about this generally. In the single parity check code, the minimum Hamming distance was 2. So therefore, any single error will flip 1 bit, and because all valid code words differ from each other by at least 2 bits, a single bit flip is guaranteed to flip a code word into something that's not a code word, and that's detectable as an error. So if I guarantee, however, there do exist at least one pair of code words, so that because dmin is 2, there exists at least one pair of code words, so that 2 errors will flip one code word to another code word. So therefore, 2 errors is not detectable. So in general, if my Hamming distance, my minimum Hamming distance is dmin, how many errors am I guaranteed to be able to correct? Or excuse me, to detect? Dmin minus 1. So for a code C with minimum Hamming distance dmin, we are guaranteed to detect up to dmin minus 1 errors. And we can't detect more than, okay, but we are guaranteed to detect up to dmin minus 1 errors. So with the single parity check code, I argue it is possible to detect an odd number of errors. So that actually goes beyond dmin. So dmin here is 2, and I can detect any odd number of errors, meaning I can detect 1, 3, 5, 7, and so on. So that actually goes beyond. But all I'm saying here is that if I give you a code with minimum distance dmin, and I don't tell you anything else about its structure, you are guaranteed to be able to correct dmin minus 1. Now there may be methods by which you can detect more errors, as there are with the single parity check code. But dmin minus 1 errors, that is at least guaranteed, without knowing anything else about the code. Any questions about that?
So there are, if let's say dmin was 3 and 2 errors occurred, even without the extra bit, we can detect that it was an error, right?
Correct. So, yeah, in fact, here's an example. So here's the simplest code in the world is called the repetition code. So let's say C is equal to, C contains 2 code words. One is 0, 0, 0, and the other one is 1, 1, 1. So first off, what's the minimum Hamming distance? I mean, there's only 2 pairs of code words, so the minimum Hamming distance is obviously 3. So how many errors can I detect? I can obviously detect 2, and in fact, you can see that if I send, let's say 0, 0, 0, and 2 errors occur, so I receive 1, 0, 1, this is obviously not a code word. And in fact, there's no way to flip 2 bits here and get a code word in either case. So therefore, I must be able to detect 2-bit errors. This is actually a nice segue into the following. So what if I have this code with dmin equals 3, and I receive this? So for one thing, an error has occurred. So now I can look at all of my possible sequences and say, okay, how can I get here from 0, 0, 0? Well, if 0, 0, 0 was transmitted, then that must have been an error. If 1, 1, 1 was transmitted, then these 2 must have been an error.